Hello, Mr. Eric, Mr. Ryan. How are you today? It's
Good.
Friday today. Okay, it's a good weekend. Yeah, starting of the weekend. Okay, so today we talk about the graph. Remember what's graph, Eric? Graph.
It's like, a graph,
Graph.
like a binary tree.
Binary tree is one of the graph. Tree is one of the graph. The linked list can be also one of the graph. Yeah, graph. Remember, graph has the vertex. Graph. Graph have this vertex, right? Vertex, and the edges, right? Yeah, alright. So this a graph. A graph we use the G to represent a graph, and it contains the two elements, two sets of elements. One is the vertex V, and it's their edges E. Okay. So for example, you know the binary tree. Yeah, binary trees are actually are the graphs, a simple graph. Right? Look at it. Look, that's 1, 2, 3. It's one special kind of graph. And look at the edges. They are not that they are not directions. Yeah, they are unidirection. Yeah. Right? Undirected graph. Right? Undirected graph. Undirected graph, because the edge does not have these directions. Yeah, all right. This is the vertex. Yeah, okay. Sometimes you got the weight. For example, you have the weight on it. Like that's 2, that's 3. That's the weight. Yeah, yeah. Okay. So today, so all right. Listen up.
Okay.
So today, given the graph in adjacence, how do you spell this one? Basically, look, Eric, basically,
J.
how do you spell adjacent? Let me check, okay? Adjacency. Adjacency. List. Okay, adjacent list. Okay, this is bad. Can I have it? So what is adjacent list?
Tried it.
Like, look, Eric. 1, 2.
Then I'm taking this one.
No, maybe we start with 0. Okay, 0. Okay, and then that's 3.
4.
Okay, so this graph, how do we represent it in this adjacent and adjacent list? Look, if we have a direction here, yeah, direction, yeah, means the edge can have a direction, right? Right. So how do we store it? We store in a list, okay? A list. We can store in a list. So the first one is 0. So we have age 0 to 1, and that's it, right? And maybe we have another one 0 to 3. So for the first element, which is 0. For the first element with 0, so we have this 0 to 1 and 3. Okay, so that's the first element of the list. And for second element, which is 1 only goes to 2, right, Eric? Look, yeah? So it's 1 and it's 2, right? This is the second element, 2. And for the third one, 3 goes to 0 only, so you put a 0 here. And the fourth, there is no fourth. Okay, so that's it. That's the adjacent. Look, there are only 0, 1, 2, 3, right? 0, 1, 2, 3. Sorry. 2 goes nothing. 2 doesn't have anything, so like that. And 3 is 0, yeah? Yeah. So this is the list. A list of lists, right? Does it make sense? The first element of list gives the edges coming out of the first element, which is 0. So it's 1 and 3. So I put a 1 and 3. Look, Eric. So what's this 2? Can you explain to me what's this 2?
That's the
first one goes to 2, right?
Yeah, that's.
Okay, and
that's
yeah.
Good.
And the third one goes to
a 0.
Okay. No. So
What?
let's no. Okay, that's 0. That's 1. That's 2. That's 2. 2 doesn't go anything, so it's empty, right? And then that's 3. Right? Does it make sense? So adjacent list is a list right? A list of lists. A list of the edges for each vertex, right? Does it make sense? Right? So now look, if I give you this graph, okay? Maybe a simple one. If I give you this graph, 0 to 1, okay? 0 to 1, and 1 to 2. Okay, I give you a list, yeah? I want you to reverse it. So you just need to represent using this kind of syntax and then just reverse the link. How do we do it?
All you need to do is check, just get a line. Wait, what if there's both like that?
Sorry? Both like that, yeah. That's a good question. Yeah, when you reverse it, it's the same, right?
Okay.
Yeah, because you look, you have two ways, and when you reverse it, what happens? Still has two, right?
Yeah.
Okay, so how do we do this?
All you need to do is reverse it.
Yeah, how do we reverse it?
Dot minus 1, I think.
Minus 1? Okay, so that may be hard to, I mean, I see this is easy to understand, but hard to code, right? So look, define, let's say reverse, reverse, we have a graph, which is the adjacent list. A list of lists, yeah? A list of lists.
Come!
Okay, can I have list, please? It's always not very nice. Okay, so now, if the graph is empty, we obviously, when we reverse it, it will be empty, right? Right? Then we just return, right? Right? Yeah? Return G, right? Right? If the graph is empty, we return graph. Okay, now we need to create a new graph, right? Let's say new graph is NG. New graph is NG. So what kind of, so when we reverse the graph, what happened to the vertex? Does it change or not? What changes? It doesn't change, right? Does it change? If there are three vertex, 1, 2, 3. When you reverse it, how many vertex are there? What are we doing with the vertex? No, I mean the vertex, not the edges. Edges we swap it.
Vertex doesn't.
Vertex doesn't change, right? That's what I meant, yeah? When you swap with when you reverse the graph, you only reverse the edges of the graph. You don't reverse the vertex, right? So in this case, how about let's allocate a space for the graph. So we allocate a list, adjacent list, right? So that will be, look, at the beginning, got empty, right? Empty. Each one is empty. Now how many of them?
As many.
4 underscore, we don't care. In range length graph, right? How many vertex are there? Length graph, yeah? Original graph, yeah? Am I right? How many vertex length are? And I want to create a copy of it. But the copy, the list, the graph is empty, right? So what's this? So original is this one, Eric. 1, 2, 3. So what's after this ng? What does ng store? What's our ng store? What's ng store?
NG store is.
After this, what happened? What's this? This is G. This represent is G. This is G. Okay? And what's ng here? Empty list for length G times. So what's happened? Length ng is what? Is the what?
No.
Can you draw? What's ng? What's ng? What did I just say about this?
NG is the length of G.
Yes, and I'm copying a list for each one. So what?
It's like bracket.
Is the bracket means what? Each edge, each vertex does not have any edges, right?
Yeah.
Yeah. So what does it mean? Can you draw the graph of ng? Come on, it's very easy. Come on.
So like.
It's just the opposite. You do the same, but the arrow the opposite.
No, it's not yet. I'm just creating this. I'm not yet. Wow, what you doing?
So it's like.
What are you drawing? Come on. This G with the edges, I'm just copying, allocating length G times. Each one does not have any edges. So what happened?
So like.
Yeah, you just need to draw. Is there any edges? Come on, that's what I'm saying. Does it have any edges?
No.
No, and but what else can it have? The vertex, yeah? Alright? So 1, okay, put the 2 here. Yeah, that's what I mean, yeah? Does it make sense? Yeah? This is the how we store the ng. But it does not have any links here because we putting it empty. But it has length g because the number of vertex does not change. Right? Does it make sense? Okay. Now we need to go through this. Go through this, right? Go through these edges. So now we do this for.
I'm not throwing them away.
That's okay. For, look, u, v in enumerate. Okay, yesterday we talked about this function. What does it mean? Enumerate graph. What does it mean?
Like you enumerate.
Yeah, enumerate it, right? Enumerate it. So u will be from, v will be 2. So you'll be a link between u to v, right? That's what it means, yeah? Yeah? Alright?
Mm-hmm.
Actually, no. Because u, okay, so that's a mistake here. U will be 0, 1, 2, 3, the vertex, right? The vertex. V will be the list of edges that u points to, right? Alright? Okay, so for example, Eric. So for example, 1 also points to 3, right? So for u, the first iteration, the u will be 0, and the v will be what? 2 and 3. It will be list of 2 and 3. Right? Yes? Yeah? Okay, so now I need to go through this each edges, which is 0, 2, 0, 3, right? Alright? 0, 2, 0, 3. And I need to reverse it, which it becomes 2 what? 2, 0, and what? Come on. Okay, so this is, okay, let's do this 0, okay? 0, 2, 0, 3. And then when I reverse it, it will be what? It will be what?
3, 0, 2, 0.
Yeah, look at u is 0. The u is 0. And then v is the number of edges it points to, right? So when I reverse it, it means that u is pointing to 2. U is pointing to 3. There are 2 edges. But now I want to reverse it. So it will be 2, 0, and 3, 0, right? So I need to go through each edges, which is what? 4.
I've got
Okay.
a nosebleed.
Okay, can you accept yeah? For k in u or v, can I have your attention, please? For k in u or v, we're going through the numbers in u or
V.
Yes.
V.
U is the from, the 0, v is 2 and 3, of course be v, yeah? Right?
Okay.
And then now what? We have these edges. We want to add the edges to the new graph, which is v what? Which is what? K. Which is what? K and what is the number? The edge, the reverse edge, which will be K what?
K vertex.
K U or V? Come on.
U.
Yeah, K or U. Then now we do this NG. Look at it. K. Eh?
Yeah.
Dot what? Dot what? Dot what U? Dot what U? NG is the list. So what method are we going to? NG dot. Which method? The opposite of pop. What's the opposite of
Pen.
a pen? Come on. Does it make sense? And then return what?
Return.
Return what? There's no answer here. Return what? What are we doing here? Which is the reverse graph?
Return reverse graph.
Where's the reverse graph? I'm telling you. Which?
NG?
Yeah. NG is the reverse graph. Does it make sense, Eric? Does it make sense?
Where?
Does it make sense, Eric?
Where?
What's the term complexity?
Something.
Okay, so if they are V and V vertex and each one has E edges, so what's the term complexity?
What?
If they are V vertex
V
and each one has
Wait.
varies if they are E edges.
V.
V vertex, and each one has E edges. I'm just saying.
Each one has E edges.
So
it's V,
and what?
E.
Yeah. The total number of edges will be V and E, right?
Yeah.
So the time complexity is OVE, right? What's the space complexity? There's no N. I mean V and huh?
OVE.
Yeah, OVE. We are returning this. Yeah, returning this copy. Yeah. All right. All right, Eric. So can you tell me which part is to reverse it? Reverse the graph. How are we doing this? Why this is reversing it?
Why this?
Yeah. So
But
what's
you
this
know-
mean? What's this mean? K in V. What's V?
V is a vertex.
Yes, it's a vertex. Which vertex?
There's
So look, what's this? What U and V? What's this mean?
U is this and V is this.
Yeah, U is each vertex we are checking, and the V will be the edges it points to, right?
Yeah.
Yeah, like 2 and 3, and then we're going through this 2 and 3, and what we do is that we add the 2 and 3 pointing back to the U, right? Right? Does it make sense?
Yeah.
Okay. Does it make sense? Yes. Does it make sense for you, Eric?
Yeah.
Yes. Yes. Okay. I think that will be it for today. Yeah. Okay, that will be it for today. Let me remove one of it. Okay. Yeah. Okay. Can you write this? Just write it in front of you.
Okay, so then we get a better pen.
Yeah. Can you do it? So what are we doing now?
So like, you know,
Yeah. So what are we doing now?
I know there's something like a pen.
Yeah, you need to understand what it means, not remember it. Okay, you need to understand first. Okay, you need to understand first. I need to buy more pens.
This one is good.
Yeah. Okay, a pen. What a pen? Yeah. A pen what? A pen what?
A pen.
What a pen what?
Okay.
So what? So which is the start of the reverse edges? So because look, we know the current edge is what? Is U to K, right? What's the reverse?
K to U.
Okay, K to U. So what K to U? How do you put it in the graph? How do you put it in the graph? If it's K to U, right?
So a pen U.
Yeah. What append U? You put append U first. Come on, append U.
So I'm not. So I
Append
do
U, yeah.
bracket.
Yeah. You don't need so heavy. You just append U. Yeah. Append U. Yeah. And what append U? So what graph are we modifying? What graph?
With
What graph are we retaining? What graph are we modifying?
K.
Graph. Which graph? Come on. Graph.
And G.
NG is the graph. Yeah. NG. NG what? Which NG which vertex?
K.
Yeah. You just said K to U, right? Because now it's U to K. Alright? Okay.
And G.
NG. Remember, NG is the list. A list of a list. Each list is the number of vertex that current vertex points to, right? So NG what?
N G K.
Yeah. How do you put an NGK? Come on. What's going?
Bracket.
Yeah, bracket. Put it there.
This bracket.
Yeah, this bracket. You're missing one thing.
Column.
No column. Dot. This is the list. You need this the method. You're calling the method dot. Yeah. Dot append. You're not putting it together. Dot append. Does it make sense now?
Yeah.
Okay. Say bye bye.
Bye.